Ever been to the zoo and just watched like a gorilla for a while?
Oh, yeah.
They're fascinating, right?
Yeah.
Just watching them learn about their world by interacting with it and observing it. It's
Yeah.
so different from how we humans often learn,
And,
especially when we get to complex topics, right?
and we're usually stuck with textbooks or,
Yeah.
staring at screens.
Exactly, glued to a screen or a textbook.
Right.
And that difference, like learning by doing and seeing versus, abstract representations like text, that's at the heart of some really groundbreaking AI research we're going to dive into today.
Yeah, really interesting stuff.
It really is. So this research focuses on an AI model called VideoWorld, and it kind of learns the way that gorilla at the zoo is exploring its environment.
Okay.
No textbooks, no labeled data, no instructions. VideoWorld learns just by processing raw video data.
Wow.
It's like watching a never-ending movie and figuring out the rules of the world just by what it sees.
That's fascinating.
Isn't that wild?
Yeah.
And to make things even more interesting, researchers wanted to see if VideoWorld trained only on video could actually tackle some really challenging tasks.
Uh-huh.
So they tested it in two very different environments. The ancient game of Go, known for being strategically complex, and then also a set of robotic manipulation tasks,
Oh, wow.
which require understanding visual cues and coordinating actions.
So you've got this AI learning from video, and then they throw it into these two completely different scenarios. Yeah. One's a game that requires all this strategic thinking and planning,
Right.
and the other one is like real-world stuff.
Yeah, more like a real-world kind of situation.
Yeah, manipulating objects in a 3D environment. It's really cool.
Yeah, so they basically threw VideoWorld into the deep end of the pool to see if it could swim.
Exactly.
Now, before we get into how it actually did, let's unpack why focusing on video as a learning source is such a big deal. I mean, as humans, think about how much we learn through sight, right? We pick up subtle cues, movements, interactions. Video allows AI to tap into that richness. So its learning process is more similar to our own visual experiences.
That makes sense. So it's not just about the data itself, it's about how that data reflects the way we learn as humans.
Right.
It's like giving the AI a more human-like way of understanding the world.
Exactly. Yeah. But I'm imagining that processing video data must be a computational nightmare. It's not like you're just feeding the AI a nice, neat text file or something.
You're telling me the sheer volume of information in a video is immense. And for AI to learn effectively from video, it needs a way to represent visual change efficiently.
Okay, what do you mean by visual change?
How things move, how they interact, and how they transform over time.
So it's not just a bunch of still images. It's about understanding the dynamics, the actions.
Exactly, cause and effect, the whole shebang.
Got it. So how did they overcome this video data hurdle? Did they have to build a supercomputer the size of a small planet or something?
No, not quite. Their solution was actually pretty elegant and powerful. They created VideoWorld, which uses an architecture similar to the ones we see in those impressive large language models that we've talked about before. But here's the twist. Instead of processing text, VideoWorld processes video.
Okay, I'm intrigued by this twist. But how does it deal with all that information without, completely choking? There's got to be some secret sauce involved here.
There is. The secret sauce is the latent dynamics model, or LDM for short. Think of the LDM as a super efficient compressor.
Okay.
It takes those complex multi-step visual changes you see in a video, and it distills them into compact, manageable codes. It's like summarizing a long movie into a series of keyframes that capture the essence of the story.
So instead of trying to remember every single pixel,
Right.
the LDM is extracting the most important information, the highlights, the turning points. I'm starting to see how this could make learning from video a lot more efficient.
Exactly. It's like giving the AI a cheat sheet for understanding the most important parts of the video.
Makes sense. So with this LDM in place, how did VideoWorld actually perform in those challenging test environments?
Well, let's start with the Go experiment, shall we?
Yeah, drumroll please. How did an AI learning solely from video do against a game known for being so strategically deep?
Prepare to be impressed. VideoWorld, powered by this LDM and trained on videos of Go games, achieved a 5 Dan ranking.
Wow, 5 Dan.
That's right.
That's like playing against a serious amateur who spent years honing their skills.
Exactly. It's a high level of proficiency.
And to think it reached that level of mastery not by being programmed with rules or strategies, but by simply observing the game being played.
That's the crazy part.
It's like it developed its own intuition about how to play Go.
It's like it was watching over someone's shoulder, learning the tricks of the trade.
Yeah.
To really compare its performance, the researchers used something called the ELO rating system.
Okay, I've heard of that.
Yeah.
It's a way to rank players in games like chess and Go, right?
Exactly. They pitted VideoWorld against different versions of Katago, which is a top-performing Go AI that uses reinforcement learning.
So VideoWorld, the video learning prodigy, is going up against a seasoned AI champion that learns through trial and error and rewards. This is getting good.
It's Clash of the Titans.
Who emerged victorious?
Well, it wasn't really about winning or losing in the traditional sense. The remarkable thing was that VideoWorld, even without all the bells and whistles of reinforcement learning, achieved a level of play comparable to these strong Katago versions.
Wow. So it was able to hold its own against a top AI opponent.
Yeah, it really shows that learning by observation, even for a complex game like Go, can be incredibly effective.
This is blowing my mind. I'm starting to understand why this research is so groundbreaking. It's not just about building an AI that can play Go, it's about exploring a fundamentally different way for AI to learn and understand the world.
You got it. It's a paradigm shift in AI.
And this LDM, it's not just some technical marvel, right? It's a window into how VideoWorld is actually learning.
Absolutely.
Wait, are you telling me we can actually peek inside VideoWorld's mind and see how it's making decisions? That sounds like something out of a sci-fi movie.
It might sound like sci-fi, but it's actually cutting-edge science. By analyzing the LDM codes, the researchers were able to get insights into the AI's thought processes.
Okay, hold on. So these LDM codes, they're not just random gibberish.
No, they're not.
They actually reflect meaningful patterns in the Go games that VideoWorld observed.
Precisely.
It's kind of like looking at a map of a city and seeing clusters of points that represent different neighborhoods or landmarks.
That's a great analogy.
And that's what they saw when they analyzed the LDM codes.
Yeah, clusters that corresponded to common Go board configurations and strategic patterns.
So it's like VideoWorld was creating its own mental map of the game. Grouping similar situations together and learning from those patterns, it's almost like watching a human player study classic Go matches and internalize those strategic concepts.
Exactly. It's a fascinating glimpse into how an AI, learning solely from visual data, can develop an understanding of complex strategies and patterns.
This is all incredibly exciting. But Go is a relatively structured environment.
Yeah, it is.
Black and white stones on a grid. What about the messy, unpredictable real world, where objects move in 3 dimensions and the rules aren't always so clear-cut? How did VideoWorld handle those robotic manipulation tasks?
Now that's where things get even more interesting. Let's dive into the world of robotics next.
Let's do it.
All right.
After a quick break, we'll be right back.
Sounds good. So those robotic manipulation tasks we talked about earlier,
Right.
the researchers challenged VideoWorld with a set of tasks in 2 different simulated environments called Calvin and RL Bench. They're kind of like virtual playgrounds for robots where they can learn to interact with objects in a 3D world.
So not robots playing Go anymore.
Right.
We're talking about robots learning to do things that could have real-world applications.
Exactly.
Like moving objects, opening drawers, turning on lights.
Exactly. And the key here is that VideoWorld wasn't given any specific instructions or rewards. It had to figure out how to do these tasks just by watching videos of other robots doing them.
It's like watching a YouTube tutorial on how to assemble furniture.
Yeah.
But instead of a human, it's a robot trying to learn from another robot's video.
I like that analogy.
Yeah.
And you might be surprised to hear that VideoWorld was actually pretty successful. It wasn't perfect, but it was able to perform these tasks reasonably well, getting closer to the performance of AI models that are trained with, explicit instructions and feedback.
That's really impressive. It suggests that this approach of learning from unlabeled video could be a game changer for robotics.
For sure.
Imagine robots that can learn new tasks quickly and adapt to new environments without needing to be reprogrammed every time.
Exactly. No more starting from scratch every time something changes.
Right. And this type of learning could extend beyond industrial settings too, right?
Let's see.
Like picture a future where household robots can learn to do chores by watching you do them.
Oh, yeah. That'd be amazing.
No more confusing instruction manuals or frustrating programming interfaces.
Exactly. Just show the robot what to do and let it learn.
It's like something out of a sci-fi movie.
It is, but it's getting closer to reality all the time.
So what's even more remarkable is that VideoWorld showed signs of generalization.
Oh, yeah.
You know those 2 environments, Calvin and RL Bench? Well, they're visually distinct, with different objects, lighting, and overall appearance. It's like learning to cook in 2 different kitchens.
Okay, I can see that.
Each with its own layout and appliances.
Right, different tools, different setups.
So the researchers wanted to see if VideoWorld could transfer what it learned in one kitchen to the other.
Could it apply its knowledge to a brand new environment?
And the results?
Well, the results were encouraging. VideoWorld was able to successfully perform tasks across both environments. It wasn't just memorizing specific movements. It was learning something more fundamental about how to interact with objects and achieve goals in a 3D world.
So it was able to take what it learned in one context and apply it to another.
Exactly. It showed real signs of generalization.
That's a big deal.
It is.
Because generalization is key for any AI system that's going to operate in the real world.
Absolutely.
Mm-hmm.
The real world is full of surprises. AI needs to be able to adapt and apply what it knows to new situations.
And this ability to generalize suggests that VideoWorld wasn't just learning a set of rules or procedures.
Right.
It was developing a more flexible understanding of the world.
Yeah, like a human child learns through exploration and play.
It's like watching a kid learn to stack blocks, you know? They might start by imitating what they see, but eventually they start experimenting, building new structures, coming up with their own creative ideas.
It's all about learning by doing and figuring things out for yourself.
I'm starting to see the power of this approach to AI learning. Instead of relying on explicit instructions, which can be limiting, VideoWorld is learning from the raw, unfiltered experience of interacting with the world, just like we humans do.
It's a more natural way for AI to learn.
And that's incredibly exciting. So this research, it's not just about building AI that can play games or do robotic tasks. It's about exploring a new paradigm for AI learning, one that's more aligned with how humans learn and understand the world.
You're absolutely right. It's a new way of thinking about AI and how we can teach it to learn.
But before we get too carried away with all the possibilities, it's important to take a step back and look at the bigger picture.
Sure.
What are the limitations of this research? What challenges still remain?
That's a good question. Remember, this research is still in its early stages. VideoWorld, as impressive as it is, has limitations.
Like what?
Well, for one thing, scaling up this approach is a major challenge. Processing video data takes a lot of computing power, and the data sets you need to train these models are enormous.
Yeah, I can imagine the amount of data involved is mind-boggling.
It is. And as the tasks get more complex, the computational demands grow even faster.
And it's not just about the quantity of data, right? The quality of the video data matters too. If the AI is learning from blurry, shaky videos, it's not going to learn very effectively.
Exactly. You need high-quality data to train these models. Garbage in, garbage out, as they say.
So data quality is crucial. What about other challenges? Are there any inherent limitations to this approach of learning from unlabeled video?
Well, one challenge is making sure the AI learns the right things from the video data.
Okay.
Unlike supervised learning, where you give the AI explicit labels and feedback. Learning from unlabeled video relies on the AI's ability to extract meaningful patterns and insights on its own.
So there's a risk that the AI could misinterpret the data, draw incorrect conclusions, or even pick up on biases or undesirable behaviors that might be present in the data?
Exactly. It's like a child learning from observing adults. If the adults are behaving badly, the child might pick up on those bad behaviors without realizing they're wrong.
That's a good point. So it's essential to carefully select and filter the video data that's used for training.
Absolutely. Data quality and bias are critical considerations.
Are there any other challenges you want to highlight?
Another big one is interpretability. With supervised learning, you can often trace the AI's decisions back to specific rules or features it's learned. But with unsupervised learning from video, it's much harder to understand why the AI is making certain decisions.
So it's like watching a magician perform a trick.
Yes.
We see the outcome, but we don't know how they did it.
That's a great analogy. And this lack of interpretability can be a problem, especially in areas like healthcare or finance, where transparency and accountability are really important.
It's like trusting a self-driving car to navigate a busy city. You want to be sure it's making safe decisions and understand why it's making those decisions.
Exactly. So while this research is really promising, it's important to acknowledge these challenges. Scaling up, ensuring data quality, addressing potential biases, improving interpretability. These are all crucial areas for future research.
It sounds like there's still a lot of work to do.
There is. But the potential payoffs are huge. Imagine AI that can learn complex skills just by watching videos, adapting to new situations, collaborating seamlessly with humans.
It's both exciting and a little bit daunting.
It is. It's a future that's rapidly approaching.
Speaking of the future, let's talk about what this research might mean for our listeners. How could AI that learns like a gorilla through observation actually impact your life?
Let's put on our futurist hats and explore some potential real-world applications.
Okay, I'm ready. Let's dive in.
All right, let's do it.
Okay, so we're back. And we're ready to explore how AI learning through observation, like our gorilla friend at the zoo, could really transform various aspects of your life. It's time to put on our futurist hats and really imagine the possibilities.
Fasten your seatbelts, because the potential applications of this technology are far-reaching and mind-boggling.
I'm ready.
Yeah.
Let's start with something tangible. We talked about VideoWorld controlling a robot arm in a simulated environment, but how could this translate into like real-world robotics?
Okay, so imagine robots in factories or warehouses, learning new tasks. Not through complex programming, but by simply watching skilled human workers.
So no more tedious line-by-line coding.
That's right. The robots could essentially learn on the job, just like a human apprentice would.
That's a huge shift. It would make industries so much more adaptable and efficient.
Absolutely.
Yeah.
Companies wouldn't have to wait for specialized programmers every time a new task or process came up.
And this could go way beyond industrial settings too, right?
Oh yeah, for sure.
Imagine household robots that could learn to do chores by watching you.
That would be a game changer.
No more confusing instruction manuals.
Right.
No more frustrating programming interfaces.
Just show the robot what to do and let it learn.
It's like a dream come true. Well, maybe a sci-fi movie coming to life. But let's not just stop at robotics. What about healthcare? I can see some incredible potential there.
Absolutely. AI systems could help doctors diagnose diseases by analyzing medical images or videos of patient examinations.
Oh.
They could learn to spot those subtle patterns or anomalies that a human eye might miss.
So earlier and more accurate diagnoses.
Exactly. And think about personalized medicine. Imagine AI that can learn from your individual data, including videos of your movements, facial expressions, even your daily routines.
It's like having a virtual health guardian angel watching over you, constantly learning and evolving to keep you healthy. It's both incredible and a bit unsettling.
Yeah, the implications of AI constantly observing and learning from our personal data definitely raise some ethical questions. But let's shift gears for a second and think about education.
Okay.
How could this type of AI change the way we learn?
Well, if AI can learn by watching videos, imagine its potential in personalized learning.
Right.
AI systems could observe students' interactions with educational materials, identify areas where they're struggling, and provide tailored support or feedback in real time.
It's like having a personal tutor for every student, adapting to their individual learning pace and style.
That's pretty cool.
It could make education more engaging, effective, and accessible to everyone.
Okay, so that's education. But what about the fun stuff? How could this tech revolutionize entertainment?
Get ready for a truly immersive experience. Imagine video games that adapt to your playing style in real time,
Whoa.
adjusting the difficulty, introducing new challenges, even changing the story based on your choices and reactions.
That takes interactive storytelling to a whole new level.
And it's not just games. Streaming services could use this to recommend content based on how you react to what you're watching.
So no more generic recommendations.
Right. Instead of just because you watched this, it's about understanding how a show makes you feel and suggesting content that evokes similar emotions.
It's like having a personal AI entertainment concierge.
Exactly. Curating your viewing experience based on your mood.
This is amazing. The possibilities really do seem endless. Self-driving cars learning from dashcam footage, security systems that can identify suspicious behavior. This tech has the potential to touch so many aspects of our lives.
It does. It really opens up a whole new world of possibilities.
But it's important to remember that with any powerful technology, there are also potential risks and challenges.
Of course. As AI gets better at learning from the real world, we need to make sure it's learning the right things.
Absolutely.
We need to be really careful about data privacy bias detection and the ethical implications of machines that can observe and learn from our every move.
It's a lot to think about, but one thing's for sure. This research is pushing the boundaries of AI in some really exciting ways.
It definitely is.
It reminds us that the future of AI isn't set in stone. It's something we're actively shaping through our choices and our actions.
Well said.
Yeah.
And as we explore this idea of AI that learns by watching, we need to have open and honest conversations about the kind of future we want.
It's a future where AI could be a powerful force for good,
Exactly.
helping us solve some of the world's toughest problems, creating a more just, equitable, and sustainable world.
It's a future worth fighting for.
Absolutely. And we all have a responsibility to guide the development of AI in a direction that benefits all of humanity.
I agree. So that's a glimpse into the world of AI that learns by watching.
We've explored its incredible capabilities.
Its potential to transform industries.
And even our daily lives.
And we've talked about the ethical considerations that we can't ignore.
We encourage you to keep exploring this topic, to join the conversation about the future of AI, and to stay curious about the ever-evolving relationship between humans and machines.
Thanks for joining us on this deep dive. Until next time.